Yeah, welcome back to Learning with Pete. It's been quite a while, and I trust you are doing great. Yeah, but we've been around, and we are back. Yeah, we'll be taking a series of new videos, a series of new lessons. So watch out for Learning with Pete. It's going to be interesting. It's going to be fun. Above all, it's going to be educative. You are really going to enjoy our new series of videos that will be coming. Yeah, and yeah, like I said, this is a channel for high school mathematics, physics, chemistry, and biology, basically science. Okay, mathematics and science, high school mathematics and science. Okay, it's going to be fun. It's going to be interactive. Yeah, and you are free to comment in the comment section below, like and share with anyone that might find these videos useful. You find these videos very helpful. Yeah, you are going to enjoy it. You are going to enjoy it. Welcome to our very first lesson in this series. Our very first lesson in this series happens to be unit conversions, units and their conversions. Okay, this is an interesting topic. This is a topic that poses a lot of challenges to a lot of young students out there, especially those coming from the junior high school to the senior high school level. Units and their conversions pose a lot of challenges. Okay, but in as much as it's challenging, it's also very interesting. Okay, so you want to pay attention to this course. Okay, it's going to be interesting. We are going to try to make things as fun and as short as possible. Okay, so can we start? Alright, so we are basically going to be talking about units and how to convert them from one form to another. Okay, but we can't talk of units without talking about what units came from. Okay, units are from, or what they represent. Okay, what units represent. Units represent physical quantities. In science, it's not new to you. Every science student knows what a physical quantity is. Okay, you come across a lot of physical quantities. Okay, but it's interesting, or it is well noted that the difference between a physical quantity and a quantity. Okay, so quantities are what we see around us every day. Currency is a physical quantity. The naira, the cedis, dollar, they are all quantities representing money. Okay, but in science, we don't talk about just any quantity. We talk about physical quantities. So I like to define what a physical quantity is to you. Okay, so this is a physical quantity. Physical quantities are any aspect of matter that can be measured. So anything at all about matter that can be measured is a physical quantity. Can be measured either by an instrument or by means of calculation. Is a physical quantity. Okay. Now there are a lot of physical quantities. Lots of physical quantities we come across in science, but scientists have tried to group them, okay, into two. We have base quantities or fundamental quantities and derived physical quantities. Okay. Now the base quantities, the good news is that even though there are lots of physical quantities, the base quantities are 7. Okay. They are called base quantities because they form the fundamentals or the base of any other derived quantity. And they are 7, so it's easy to keep them in mind. Okay. You can't keep all the derived quantities in your head because even as science progresses, new physical quantities keep on coming. Okay, so we are glad that we have only 7 base physical quantities so that we can commit them to memory. Okay, alright. So the 7 base physical quantities are listed here: time, mass, length, temperature, electric current, not electric field, amount of substance, luminous intensity. Okay. Alright, so after talking about physical quantities, let's then talk about the main scope of this course, okay, of this video. Okay, so what are units? Okay, let's see what are the units of what are the definitions of units. Okay, units are symbols in which values of physical quantities are recorded in. Symbols in which values of physical quantities are recorded in. Those symbols can be letters or any other thing. Okay, but they are not usually letters. Okay, or they are not most of the time letters. For example, you see here, this is resistance. Okay, so let's say the resistance of a wire or a piece of wire is 50 ohms. 50 ohms. Here, the 50 is a value. Okay, but for us to see that it is resistance, we have to see the units there. Okay, and so the unit of resistance is ohms, and this is the symbol for ohms. Okay, so this is a unit. Ohms is a unit. It's a derived unit for electrical resistance. Okay, so now that we know what we finished talking about physical quantities and units. Okay, let's go a bit ahead. Okay, and talk about the types of units. What are the types of units? You need to understand that units, there are 2 unit systems in the world. We have the metric system and we have the imperial system. The metric system and the imperial system of units. We have the metric system and the imperial system of units. Now, the whole world uses the metric system, but the US and 2 other countries, Liberia and another country, uses the imperial system. The imperial system is the system of the British. Okay, though the British no more use the imperial system, they were the originators of the imperial system. So the imperial system is where you hear of units like yard, foot or feet, you hear of ounces, you hear of pounds, you hear of miles. Okay, those are units of the imperial. You hear of inches. Okay, now a lot of people, the world is gearing towards the metric system. Like I said, only 3 countries use the imperial system. Okay, and as a science student, you should understand the metric system more, because the science has now accepted the metric system as a standard system of units. Okay, for science textbook or science test. Alright, so we'll be sticking to the metric system. The metric system is where you hear of the gram, the kilogram, you hear of meters, you hear of centimeters, you hear of things like that. That is the metric system. And that is what the whole world is adopted now. And that is what has been adopted in our science textbooks. Okay. Yeah, with that being said, we are going to strictly be sticking to the metric system of units. Okay. Now, the metric system of units, there are a lot of units as well. For example, if you take length alone, we have the meter, we have the centimeter, we have the decimeter, we have the kilometer, we have the millimeter, and so forth and so on. So there are actually a lot of units. For that to ensure consistency, okay, in scientific tests, okay, scientists have agreed to use a standard unit, okay, a base unit, and that those base units are what we call SI units. SI units. They are standard units that we use in the metric system in science. Okay, so if I measure length, I'll say the length that I've measured is 50 meters. All scientists have agreed to record length in meters. Okay, that's what it means for it to be an SI unit or a standard unit. Okay. From primary school, the normal thing we're taught is to use rote memorization, converting between units. Okay, that means that you have to know in memory. Okay, that this is how much of a unit equals another unit. Okay, that is what we call a conversion factor. You have to know that 20 centimeters, for example, you have to know that 100 centimeters equals 1 meter. Okay, you have to know this conversion factor. This is what we call a conversion factor. To be able to convert from centimeters to meters. For example, if I give you, because you know this, if I ask you to convert 20 centimeters in 20 meters into centimeters, what you will do is because you know this conversion factor, you ask yourself, okay, how 100 centimeters make 1 meter. So if I have a 20 meters, 1 meter equals 100 centimeters. If I have 20 meters, it should give me more centimeters. Okay, and the factor that I'll use to know how I get my answer is I'm going to multiply this 20 meters by this conversion factor of 100. So I will say my answer is 20 times 100 in centimeters. So that gives me 2000 centimeters. Okay, without knowing this conversion factor, I wouldn't have been able to do this conversion. It would have been difficult for me. But now, this can't help us anymore. This rote memorization can't help us anymore because you can't keep all the conversion factors in your head. Okay, even if you do, if I ask you to convert maybe 1 millimeter square to decimeter square, how do you do this? Even if you knew the conversion factor between millimeters and decimeters, how about I square it? Or how about I cube it? I say convert 1 decimeter cube to centimeter cube. How do you do this? Or how do you even do the one that has several units? If I write the density of water is 1000 kilogram per centimeter cube, kilogram per meter cube, and I ask you to convert this value, okay, convert this value into grams per centimeter cube. How do you do that? You have to know the conversion factor even for this, and that is difficult. That makes it really difficult, okay, especially for students coming from primary school. it's become junior high school to the senior high school, it becomes really difficult. Memorization cannot help you anymore. So you have to devise a new way. And the good news is that there is a new way, there's an easy way. Okay, that is what we are going to be looking at. This new way that we are going to be studying, okay, requires that you use prefixes. Prefixes, yes, you heard it right. Prefixes. Okay, and you know, prefixes is an English word. Okay, a prefix is just a word that comes before a main word. For example, if I write this word, believe or believing, this is a word. Okay, and if I add words before this to make it a new word or to change the meaning, you know, believing is not the same as unbelieving. So obviously, I am putting a new word out of this. Okay, by adding a word before it, and that word I added before it makes it what? Makes that word a prefix. It makes that U and a prefix because it comes before the main word, which is believing. Okay, basically that's what we are going to be doing. I'm going to be learning prefixes, and that is what is going to help us to convert between units. Okay, so you need to know some prefixes. But here, the prefixes have value. They have decimal values. They have mathematical values. Okay. Like I said, each of the prefixes has a symbol and a numerical value. So what I'm going to do is I'm going to write each of the prefixes here, their numerical value, and the symbol that represents them. Okay, so I like to do my here. I'm starting from 10. Then 10 to the 0.1, and then 0.01, 0.001. Now the zeros are becoming a lot, so I'm going to shift to writing it in standard form. So this is the next is 10 to the power negative 6, 10 to the power negative 9, 10 to the power negative 12, 10 to the power negative 15. Okay, it's very important that you understand that 0.001 is the same as 1 over 1,000. Okay, and instead of from that is 1 times 10 to the power negative 3, or simply 10 to the power negative 3. Okay, so 10 to the power negative 6 means that 0.00000, yes, 1. That is 1, 2, 3, 4, 5, 6. Okay, 5 zeros means 10 to the power negative 6. That means that 1 over a million, and that makes it 10 to the power negative 6. It's very important that you understand that. Okay, so I'll stop here and I'll continue at the top. Okay, we have prefixes for 10 to the power 2, that is 100, 10 to the power 3, 1,000, 10 to the power 6, a million, 10 to the power 9, 10 to the power 12, 10 to the power 15, and so on and so forth. Okay. Now, each of these numerical values here represent a prefix, so I'm going to write their names behind it. Deca, this is representing a prefix called deca. This represents a prefix called deci. This is representing centi. This is the value of centi, the numerical value of centi. This is mil. This is micro. This is nano, pico, femto, and then so forth. It doesn't end here, and so on and so forth. This is representing hecto. This is representing kilo. This is mega. This is giga. This is tera, and so on and so forth. Okay. Alright, now all of these prefixes have a symbol. Okay, and that is the symbol is what we commonly use. So it's very important that you note the symbols. Okay, and also important that the symbols used to represent them are letters. Okay, and we have some of them being in the capital, in the upper case, and some in the lower case. Okay, and so you should be able to distinguish which are in the lower case and which are in the upper case. It's really important. Okay, so those we need here usually are in lower case. So deca is represented by DA. This deci is D. Centi is just a small c. Mil is M. Micro is represented by mil, a big letter mil. Nano, small n. Pico, P. Femto, P. And hecto, H. Kilo, K. Mega,